Okay, so here we go. First up, I'd like you to write down this vector, 1, 2, 4. You should be able to tell me a few things, one of which is its magnitude. Its direction is what it says. 1 in the I, 2 in the J, and 4 in the K. But what's its magnitude? Would you agree that its magnitude is same as the distance that it is traveling? I think some of you didn't hear that because they were talking. I'm going to say that one more time. Would you agree that the magnitude is the same as the distance that it is traveling? Okay. And it is square root of 1 plus 4 plus 16, square root of 21. Raise your hand if you had that one right. Okay, awesome. Now, this one's hard to picture, but up in the front there, Mr. Blue Shirt. Okay. Thank you. Talking twice within the first 1 minute. Bad sign. Okay. So square root of 21 is also the speed. I want you to think about that for a second. If that's the distance it goes, how long does it take to do that? Well, 1 unit of time. Like from whenever it starts to whenever it stops. And they'll have to tell you that. Like for instance, they'll say that the time is measured in seconds and the distance is measured in miles. So that could be square root of 21 miles, which would be like what? Well, square root of 16 would be 4. Square root of 25 would be 5. So that's like 4.5. You paying attention? 4.5 miles per second. That's going really fast. It's like outer space kind of speeds where there's no gravity, no friction. All right. This vector right here, x, y, z, 1, 2, 3. Ooh, it's starting at 1, 2, 3, and it's going to 4 in the I direction, over 4. Like in the room I'm showing kids on the 3D thing, over 4, up 0, so not up at all, and out 1. And it's a vector that basically heads in that direction. Okay? And it starts at 1, 2, 3. Over 1, up 2, back 3. So it starts about here, and then it goes 4 over, not up, and back 1. So it's kind of like this. All right, so there's a vector up there. What's its speed? Assume the same deal, except, no, actually, let's do it a little different. I'll do the same units as what's on the homework. Seconds for time, meters for distance. What's its speed? Now, kids get confused on this one because they're like, I don't know if I should use the 1, 2, 3 or the 4, 0, 1. Aha! Thank you. Sweet. $5 closer to more titanium. Pausing for a second. All right, next one. You don't use this. If you want the speed, it's all about where it's moving and how far it's moving. It's moving that far. And how long? Well, it's moving how far? Square root of 17. And then it's in meters per second. So square root of 17 meters per second. All right, last one, and this one will work out nice. 1, 2, 2. And this is in miles. That's how many miles it goes. And then the time is going to be in hours. It's 1, but 1 what? 1 hour. It takes 1 hour to go this far, and that makes it miles per hour. What is the answer, Mr. B? L. Yes, because this is the one that's the square root of 4 and 1 makes 9. Those are squared. And then square root of 9 is 3, and so it's 3 ph, miles per hour. So speed is just simply the magnitude, except with units on it. Do you get that? It's just the magnitude again. All right, next, a review of the last thing we did, which was you had 2 angles, or sorry, you had two vectors, like one's going here, one's going here, and then we figured out what the angle was between them. Okay, there's a formula for that. Would you please write down the formula for the angle between two vectors? In case you forgot it, it starts with A. Okay, do you have a question, sir?
So if we're finding like speed and direction,
and I hear you that you could call it velocity, absolutely. They're going to ask you the question on our test. It's going to be called speed. And in a physics test, I could very well see it being called velocity. Okay. Did you say A dot B? And I should use lowercase letters for this. Magnitude A, magnitude B, cosine theta. All right. If you watched the video, you'd have been caught up on that. Okay. All right. Of course, the internet needs an iPad to work, because it's too bad you couldn't like watch it on a phone or something, because of course YouTube doesn't work. Oh yeah, right now he's not supposed to be watching it right now. All right, Mr. WM, what if I solve it for cosine? If I get the cosine alone, what do I divide both sides by to get cosine alone? Yep. Sometimes you will see the formula looking this way. All I did was divide both sides by the magnitude of A and B, and there it is. And then how do you always solve this thing? With inverse what? Inverse cosine. Inverse cosine will solve it. Because you'll know A dot B, and you'll know magnitude A, and you'll know magnitude B, and then all you got to do is inverse cosine at the end. Tell me why you'll never have an answer of 181 degrees. What's the biggest inverse cosine can be? Pi, which is what? 180. So you can't have a 181 degree angle. What do you mean? Like it's impossible to make two vectors with a 181? No, it's just then we'd start calling it a 179 because we go the other way. All right. Okay, so that's enough review on that. Now, the next thing. Tell me if these two vectors touch, and you want to write them both down very carefully. That vector and this vector. Just realized I goofed up that top one. Sorry, everybody note it's not x, y, y. It's x, y, z. Okay, and this x, y, z is 2, 3, 4 plus -1, -7, 0. Now those vectors ever going to touch? Will they ever go through the same exact place? Will they ever be in the same exact place? Yeah, what's that place? The starting point. They're going to start at the exact same place, and then logically they're going to be there at the exact same time, which is time equals what? Time equals 0. Because if time equals 0, then do you get how it doesn't move? And so it's just that. Time equals 0 doesn't move. They're in the same spot at the same time at time equals 0. Okay, so those two are a great example of two vectors that will collide instantly. The second you start your experiment, they're in the same spot at the same time, they're done. They have collided. Okay. How do you tell if it's not that simple? If they don't start at the same spot, how do you tell if two vectors collide? And one of the things you've got to get straight is, I'm going to go back to this one so you don't have to rewrite a bunch of things. Just tell me where this one is at lambda equals 0, and at lambda equals 1, and at lambda equals 2. It's going to be here, and then there. Those are, I should leave more room for them. They're little vectors like 2, 3, 5, 107, that kind of thing. What point is it at in 3D space at time 0, at time 1, and time 2? At time 0, it's pretty easy. Where are they at time 0? 2, 3, 4. Good. Where are they at time 1, Mr. RH? You do it in your head, just do it fast. Yeah. You're putting in a 1 right here. You're giving somebody crap, so I decided to see if you were paying attention. 3 plus 7, aka 10. And at the end, there you go. 3, 10, 4. And then the last spot that they will be at, Miss ER. Put in a 2. Tell me what you get. If I put a 2 here, I got to do that times that. Let me give you that hint. And don't forget to include this original starting point. There you go. So you got 4 for the first one. And then 17 in the last one. There we go. 4, 17, 4. So can you imagine me doing that for the other vector? Now this one happens to start in the same exact spot. So obviously, as soon as I write down t or the lambda equals 0 for this one, I would get the same 0.2, 3, 4, and I'd be like, yay, they're in the same spot at the same time. See, you could do that. That'd be a way to check your answer, but it's a really difficult way to find the answer. To make a list of all the points that it's at different times. That's a really, really slow way. So, and it also wouldn't work if it happened to meet at like 1.5 seconds. You would never checked because you would have checked 1, you would have checked 2, but you wouldn't have checked 1.5. All right, so here it is, the big hoo-ha new thing for today. You ready? If I have this vector, you want to take good notes on this so you have one really good, thorough example problem. Okay? XYZ, -2, 4, 3, plus lambda 4, -1, 1. And then I'm going to use a whole different color so it makes it really clear. This is a different vector. X, Y, Z. Different starting point. 2, 3, 4. Plus t times 1, -4, 3. Just make sure every single number is right. If you mess up one little negative sign, it's not going to touch in the right spot. It's going to end up not colliding. Okay, so there I've got 2 vectors. Do they start in the same spot? No. What do you get if you were to launch in the right direction? You can get one vector to hit another vector from any starting spot. If I set them up right, I can get them to hit. It's kind of like what you do if you're trying to shoot down a missile. We've got the ability to shoot down missiles. So if you hold this up, this is like a missile it's about to launch, and if we extend it on its route, we could take a vector, a starting point over here, and launch, and as long as I calculate it right, I should get that one after like 2 seconds. I should be able to have this one after 2 seconds intercept it. Is it possible that he could launch that at time 0 and I could launch mine at time 5 because it takes me a while to react? Like, I didn't know he was going to launch the missile. So 5 seconds later, I launched this missile, but still set up 2 vector equations to hit. That's something like what you do if you're trying to do the Patriot missile system that the United States has. Say that again? It's a good question. It is very accurate now. The very first time they tried it, it was not super accurate, but they've got it to be very accurate now. But there's different kinds of missiles out there. The simple, slow ones, those are easy to intercept and hit. But there are some that travel insanely fast, like they're going thousands of miles per hour. As you can imagine, those are very hard to hit. So because they're really fast missiles. The ICBM, Intercontinental Ballistic Missile, the ones that go between continents, you know, the ones that go up into the atmosphere. They go up into the atmosphere, and then they travel way up out of the atmosphere, and then they come back down. And so when they hit, they're traveling almost straight down. Can you imagine how hard it is to hit something like that? So anyway, so imagine for a moment that we have these two, and we need to see if they hit each other. Well, the first thing you're going to do is some multiplication, and I bet you're going to see where I get it. X equals -2 plus 4 lambda. Look around, try to figure out where I got that from. Do you see where I got that from? The very top line of my red equation. How about the next one? Y equals, keep going, Mr. CW. I'm going to just say plus -1, which is the same as minus just lambda. I like it. It will clean it up. We got rid of a couple things. Didn't need the extra plus, and we didn't need a 1 on the lambda. Okay. Mr. DB, could you read me the next one? Three plus lambda. Now, some people get bothered by the fact that, wait a minute, how come the one is lambda and the other one's t? Because they're different vectors. So they have different counters. If I said they were both t, then that would mean they'd have to launch at the same time. You get what I'm saying? Remember me talking about how if you had one missile catching up to another missile, the first one would have to get launched first before the missile system even notices, oh, something to shoot down. And then like 5 seconds later, it can launch its missile. So you have two separate counters because these might get launched at different times. One might start at time 0, the other might start at time 5. Okay, so now the blue ones, I'm going to make x equals 2 plus t and y equals, you should be able to finish this if you know what I'm doing. Go ahead and finish. You have 6 equations. The hard part is, what do you think I'm going to do next? Mr. RW, finish off these last two. 3 minus 4t, and the last one? Give me a way to solve it. ZL, I bet you can do it. Is that what equal to what? Yeah! There's an x equation here and there's an x equation here. Can't they equal each other? They absolutely can. Tell me that equation. Perfect. Now, I know that's going to bother some people because, like, well, I can't solve that. It's got 2 variables. You're right. But we're going to have actually 3 equations. Mr. B in the back row. What's the next equation? Yep. Now, I'm going to stop for just a second there and go, yeah, I have 2 variables and 2 equations. That right there is enough to solve it. But when you're in 3 dimensions, to get these 2 rulers here, if I make them cross, they're crossing right now and they're touching in all 3 dimensions, x, y, and z. But if I were to make them separate like this, only one of my dimensions is off. Only my y dimension is off. But yet, they aren't actually touching if I go this way. You get what I'm saying? You need all 3 dimensions. 2 dimensions can cross and you've got a touching spot. But if the third equation doesn't corroborate it, then you don't really have a 3-dimensional meeting spot. So bottom line, I need all 3 equations. Would you read me the last equation? 3 plus lambda equals 4 plus 3t. And that again came from that equaling that. Very nice. Okay. Ever heard of a system of equations before? You solve it by substitution or by elimination. I'm going to solve it by substitution. And you need to also, and you need to show your work. And I'm going to just use these two. I could have used either two. I'm just going to pick those two because it doesn't really matter. But at the end, you see if I remember to check the third equation. Because if I don't check the third equation, then I've got a wrong answer that I think is right. Unless you check it in the third equation, you can't know. All right, so let's find out. That is not easy to solve for. Lambda, because I'd have to add 2 and divide by 4. But what's easy to solve for? Yeah, that one, because I just have to minus 2, and then I get t alone. Go ahead and do that. I'm bringing it over here, except I'm subtracting 2 from each side. Yay, it's solved for t. Now that it's solved for t, I can put that in to the other equation wherever I see a t. And I see a t right there. So I'm going to pull that green equation out, except I'm going to replace the t with something. And the t was this, because it says t is that. Negative 4 plus 4 lambda. And now, yeah, multiply it all out. And this is where, like, oh, there's so many steps. Yes, there is. And I'm telling you, this is the part where, just like your calculus teachers are going to say next year, this pre-calc stuff isn't that hard. It's just the algebra. And they're going to be saying that in calculus too. The calculus isn't hard. It's just the algebra of it. That's why I do the top 20, to try to make sure you are above average in algebra. I'm not saying you're all perfect. If you'd all get up to 19 out of 20, then I could say that. Some of you just don't have the patience for it. Well, same thing's going to happen to you in AP Calc, because that's where you're going to lose the points, is the algebra. So master that top 20 and help you so much. Okay, I'm going to finish this puppy. 4 minus lambda equals 3 plus 16 minus 16 lambda. Now, a lot of people don't know this trick, but you would if you'd have been paying attention on the top 20. You get rid of the smaller of the two variables. Which one's smaller, negative 1 lambda or negative 16 lambda? Negative 16. Now, why is it smarter to get rid of that one? Because then you no longer will have negative signs on your variable. Now it's as easy as pie. Not even any negatives in it. You subtract 4 from both sides. 15 lambda equals 15. So lambda equals 1. Yay. Does that tell me they collide? Nope. What that says is if they're going to collide, it's going to be at time 1 for lambda. I don't even know what t is yet. There's no way I can tell if these are colliding yet. I just know that if they're going to collide, it's going to be at time 1 for lambda, which is this top equation. That's got to be a 1. Do you get where it will be at time 1? If you put a 1 right here, you'd know where they would hit. All right, but wouldn't it be nice to also know t? So when you're done, in case you forgot this about solving systems of equations, when you get the first answer, like x equals 2, you got to then go back and figure out what the y answer is. So what do I do on this one, Mr. RV? Yep, so lambda is 1, goes where? Well, I get to pick. What you want to do it in, the red, the green, or the blue equation? The green equation. We'll put in a 1. 4 minus 1 is 3. I'm going to draw it over here. 3 equals 3 minus 4t. Subtracting 3, 0 equals negative 4t. And some people freak out when there's a 0, like, oh, I did something wrong. No, you didn't. And then I'm dividing by negative 4. 0 divided by something is just 0. Woo, t equals 0. Watch what happens when I put a t equals 0 in here and a lambda equals 1 in there. Well, if t equals 0, this just cancels, and it's at the point 2, 3, 4. The question is, does the other one end up at the point 2, 3, 4? When I put a 1 right here, I got to go -2 plus 1 times 4, which makes +2. Good sign. And then we'll put in 4 plus 1 times -1, and that's going to be 4 minus 1, which is 3. And I just have to check one more point. 3 plus 1 times 1, which makes 4. 2, 3, 4. They're both at the point 2, 3, 4. Are they there at the same exact time? No. What does that mean? That means they both went through the point 2, 3, 4. But they did it at different times. One of them did it at time 1. One of them did it at time 0. Does that mean it's a failure? No. We know that they went through the exact same spot in 3D space. But one of them did it earlier than the other one did it. And so therefore, remember me saying these are like a little man running on the ruler? The two rulers can cross, and yet if I hold them up like this, the kids in class can see this. You can tell that if they start at the end of the ruler at the same time, and they're running at the same speed, then they're not going to touch. The little man running on the rulers would not end up colliding with each other. Okay? But they go through the same spot. That doorway on the way out, all of you are going to go through that spot. This spot right about here. I'll make it short for the short people. That spot right there. You're all going to go through that space where my hand is. I bet you there's been maybe 30,000 people that have gone through that space. And yes, you can always avoid it if you want to. But there's probably been 30,000 people through that space even just this year. If you add it all up, I bet there's 1 million people who have gone through that space. If we go back in time and like make it before the school was even here, it could have been like some kid running on a field going through this space. Because there's a lot of things that have been in that spot, just not at the same time. There's two things in the same spot at the same time, then they're colliding. All right. I think you get the idea. So I gave you an example here of things that intersected but did not collide. But wait, you showed me they were at the same space. Yeah, but they weren't there at the same time. One of them was at time 0 and one of them was at time 1. Okay. That's the hardest kind of problem that you'd need to know for your test. It's not that hard. It's just setting up systems of equations and solving them. Take a wild guess what you're doing for homework, one of those. And frankly, it's only one of those. But they also ask you to figure out the vector, you know how they're going to eventually touch, right? Do you get that that means they create an angle too? The angle of the two vectors. You learned that yesterday. That's that A dot B equals magnitude A, magnitude B. That's in there too. It's also got speed in there. So it covers everything that we've talked about. One big homework problem. But there's one other type of question that I have to show you real quick. And then we'll be done. And honestly, I'm not sure that if I show you this now, which I want to, then I'm not sure there's even anything left. And when's your test? You would think it would be on Wednesday, but no. It's not till Friday. Why? Because we're going to do a little bit of lab in there. And this lab is the one where you have bowling balls that create vectors. You have a vector for this one, a vector for that one, and then do you get, if you can make the bowling balls be in the same spot at the same time, then you've got the right system of equations set up. You'll be able to set the bowling balls up and go at the right angles to be able to see where to make them hit. Yes? The lab is going to not be this week. It's going to be next week. Monday, Tuesday, or Wednesday of next week. Kind of depends because we all have to use the commons. And there's 11 pre-calc classes. So it happens to be, we don't want to be in the same place at the same time. Okay, so anyway. Here is your homework. Everybody find the file. It looks like this. And this question, number 9, is, that's a real peach. The one about the plane. Anybody know what kind of plane that is? Pause for a second. All right, I just meant it's got 2 wings, so it's a biplane. That makes them, they can fly upside down. They were a real huge advance when they first happen. All right, so we're doing this whole problem from start to finish. I'm going to cross this off. I'm going to talk you through this one. Here's the first model airplane. Then it says show that its position vector after t minutes is given by this. All right, this is two different planes. This is the first plane. This is the second plane. The second model airplane starts here, and after 2 minutes, it's at this point. And you might be thinking like, well, wait a minute, that doesn't match up with this. It does. You just have to factor in that it was a t equals 2. So I got two equations. This kind of looked like last time. We have an equation for the first plane and an equation for the second plane. And what did we do? We made 3 separate equations for each of them and then matched them up. It asks what the speed of this airplane is. Do you get, I don't really care where it started. That told me how far it went in 1 minute. And that's a distance, and that's therefore in meters. So my units for my speed would be in minutes, like miles per hour, except it's meters per minute. Okay, so you just got to find its speed, which is, remember, it's just like the magnitude. It's just the magnitude again. It just has units on it now. Okay, and then last but not least, the angle between the paths of the two airplanes, if you want to put the formula down there to remind yourself. And then you're going to be confused maybe. Which of these do you use? That is the angle of where it's going. And that's the things you have to compare when you're trying to find the angles between them. Those are called the direction vectors, the ones I circled in blue. Those are what you use to find the angle between. Okay, so there is the one problem. That's pretty small. I'm asking you to do for tonight. So there's one other thing besides this, and I got to show you this one other thing. I'm going to pause for a second to get clean workspace. Did you also get a blank page in front of you? Get off the sides of the document or whatever in between things. Got to put some blank space. I think you know how to change things into from vector into parametric. But can you go backwards? Can you go all the way backwards? Let's say I had that. Would you agree that is not vector and it is not parametric? That means you could either call it, there's two different names that'd be okay. Rectangular or starts with a C. Car something. Cartesian. All right, this is Cartesian. How in the heck are we going to get it backwards, like reverse engineer it all the way back to a vector? Watch. Do you get this would have been broken off? And this little piece right here would have been that equaled t. You know what I'm talking about? And the other one, this part, that would have come from t equals that. You know what I'm talking about? And that was back when they were in which form? Which form has t's in it? Parametric. Now we got to solve this for y, and we'd have a y equals equation and an x equals equation. Does that sound familiar? Go ahead and do that. Come on. I know I'm pushing you hard, but this is the last few minutes of the new stuff. We're going backwards, solving it for x. Yes?
Is that a 2 or a 3?
That is a 2. That's a 2, and that's a 2. What you're going to note is that I always put a slash through my z's. That's how you can tell if they're a z or not. If I had put a little slash through there, that would have been a z. Okay, so it's a 2. So I'm trying to solve now and solve this for y equals. So I would end up multiplying both sides by 2 and then subtracting 3, 2t minus 3. And over here, all I got to do is times both sides by 7 and x equals 7t. If I write them side by side, it'll make total sense. X equals 7t and y equals 2t plus 3. Doesn't that look like parametric form? You get how I did that? I broke this up and said t equals this, and I said t equals that. And then I solved them for x and y, and I got this. But wait, there's more. Then I can change that into a vector equation. You remember how vector equations always look like this? Starting point t times something. Got it? You're right, there's a minus 3 in there. That is supposed to be a minus 3. Very good. Good catch. Okay, final answer. 7t, and then could I say plus 0? Yep. And y equals 2t and a negative 3, 2 for the t and a negative 3. There we go. Vector form. And I know that went kind of fast, so I'm going to give you one more. Nice, clean, just like last time. This time it'll be y over 8 equals x plus 4 over 2. Remember, each of those used to be t equals things. Reverse engineer it all the way back to a vector form of the equation. Come on, you can do this. Keep focused for 2 more minutes. WV in the back. How do I start? Okay, so this starter has to equal what? First of all, did you set that equal to t? I'm hoping. Did you remember to do that or not?
Yeah.
Excellent. And then you multiply both sides by what? And y equals 8t. Raise your hand if you had that one right. Okay, awesome. The other one, EK. Can you tell me how to do that with this? All right, so I'm going to say, first of all, set this equal to what? Yep. And then I'm going to multiply both sides by 2. And what did you do next? Yep. And I have x equals 2t minus 4. Sweet. Y equals 8t, and x equals 2t minus 4. And I'm still not done. Why not, Mr. W? This is parametric. You want the other form? Remember what it's called? Yes. So let's get this into vector form. These out of here. And what was this one again? 2t minus 4. Okay. So now I have to make, here's how it helps me anyway. I write what it always looks like to have a vector form. And I could use lambda or t. I'll use t. There we go. And I just got to know where's my starting point. That's not what it gets multiplied. This is what gets multiplied by the t. That's not that hard. So that's the thing that gets multiplied on the x's, and this is the thing that gets multiplied on the y's. And so the x goes with the 2. Nope, wrong spot. 2. And the y goes with an 8 here. And then the starting point on the x would be -4. And the starting point on the y would be, well, I guess you could say +0. There it is. Vector form. That's a long day. Okay. You have one question on the plane, and then I want you to do one other question. And that is, we're going to go back in here, and right above the plane, scroll up a little bit. 12-minute warning, it's perfect. We're going to start the homework. And where's a good one? I don't like any of those. Let's go to number 7. 7s are lucky. Let's do this one. My best advice on something like this is to rearrange it so that there's a little something going on with it at least. Like for instance, do you get if I subtract 2 from both sides, I'll have something with the y and something with the x. It's just going to make more sense to you if you have something there. If you just have a y, just a y, you would be confused about why you would set it equal to t. You could do that, but I think this makes more sense. You'll see they do that on the key too. And now you're going to take this and set it equal to t, and that and set it equal to t. And then you'll try to solve them for x and y, and you'll have one of these. X equals something, and y equals something, and that's parametric. And then you'll change it into one of these. A vector equation. Try that for number 7a. That is as small as I can make your homework and still make it helpful. You'll practice each thing that I taught you just now. And that is the toughest day this unit. From here, it's just going to be review days. Bunch of review days, a little bit of lab, test Friday. Between now and Friday, you're also going to get your take-home final. You remember how last time there was a take-home final? It counted as 1/3 of your grade for your final, 1/3 of the final. So at least you can control that part. You could go in, and some of you did not take advantage of that last time, and it really hurt your overall grade. If you can come out with an A or maybe a B on your take-home part, which you could spend weeks on, and you can ask other people for help, you can work with them on it. If you can't do that, then you're really setting yourself up for a bad grade because A, you didn't practice stuff, and B, you already got 1/3 of the grade locked in at a low grade, so it could really hurt you. Or you could play it the other way. This could really help you by doing all this stuff to practice on this take-home and working with other people and learning this stuff. You're reviewing everything you need to know for the final, not necessarily everything, but a lot of it. And you can lock in a good grade to start with. And then you go into your final with at least 1/3 of it already locked in at a good grade. Okay, so that's going to come out this week too. So there'll be plenty to do this week, but the test isn't until Friday. And that's all I got for you for today.